So hello everyone. In the last session we have seen about the basic concepts about current and electricity. Basically we have revised our class 10th concept and then we went for the new concepts. Now in today's class we are going to continue our discussion on the resistance, because in the last class we have derived the formula for resistance, that is 2 ml into 2 ml divided by Ne square E into tau, and from here we get we also prove the Ohm's law. Now in today's session we are going to solve the more like basically we are going to understand what is basically a resistance and how to find the resistance. Okay, so let us start our session. So I hope you have revised all this formula. Basically for you I have written all the formulas. If you see here, so I just want you to just go through all this formula because you have to remember it. Okay, so we can start now. Okay, so let us start. Our first concept we are going to see, that is resistance in this class. That is resistance. Okay. Now the thing is that what is resistance? Basically we know that, sir, resistance is nothing but rho L by A, or if I write exact formula, that is nothing but 2 ml divided by N square E into tau. That is the exact formula is there. Okay, but we don't need this formula. Okay, generally we do the calculation by using this. So the formula is rho L by A, but my question is, question arises, but what is L and what is A? What is L and what is A? That is a question. Length can be anything or area can be anything. What is exactly it is? So basically the length L is a length which is along the direction of current, and A is an area perpendicular to the direction of current. Are you getting my point? Correct. Are you getting my point? So this is the basically length and area is. Let me take one example so that it will be more clear for you. So let us take one example. Okay, suppose this is a cube and suppose this side is A, side is B, this side is cuboid, not cube. Okay, suppose the current is going like this. So what will be the resistance? Suppose the rho is given, this substance the resistivity is rho, then what will be the resistance if the current is going like this, I1? So what is R1? So what is the formula? First thing, the length L should be the length which is along the direction of current. See, the current is going in this direction. So which length is along means in the same direction of the current. If you see this length, what is this length? This length is nothing but A. This length is nothing but A. So our length will be A. Now what is area? Area that is perpendicular to the current. See, this is my current. So which area is perpendicular? This area. What is this area? That is this side. What is this side? This is C into B. C into B. So my area will be BC. So that is my resistance. Are you getting my point? Now suppose if the current is going like this, I2, then what is my R2? I hope this is visible to you. It is, but let me write properly. R2 rho. Now what you tell me, what is this length? The current is going like this. So which length is parallel to the direction of current? Which length? The length is C. Correct. What is the area? See, this area is perpendicular. So what is the area? That is B into A. So my area will be B into A. Are you getting my point? Similarly, let us suppose the current is going inside. This cross means the current is going like this. Okay, suppose this current is I3. Now can you tell me what is my R3 resistance? Now you have to write. I won't write. Just write it down. Write it in your notebook and match the answer with me. Okay, what is the value? I will not show you. You have to write it down by yourself. I will not show you. Just you have to write it by yourself. Everyone please write it. What is the value you are getting? Completed? Can I show? Okay. So this should be the answer. Rho B by AC, because this side is along the length and this area is perpendicular to the length. Correct? Clear? So this is how you have to write the resistance. Any doubt? Any doubt is there? Okay. Please note it down. Completed? Okay. Let us talk about another thing. Let's take some more example. Let us understand some more example. Okay. Take more example and try to understand better way. Suppose, okay, this is a solid cylinder basically. Okay, means solid coaxial cylinders are there too. Okay, suppose this radius, smaller radius is R1. Okay, and the bigger radius is R2. Correct? And my current is going like this, I, and this length is L. So what is my resistance? Are you getting my point? Means the current is going like this. Okay, so what is my resistance? First tell me what is the, like, rho, what is the length? L, what is area? Pi R2 square minus R1 square. Correct? Any doubt is there? Simple thing. Are you getting the point? Clear? Okay. Let's take one more example. We will understand it better, in a better way. Okay. We will go very slowly and try to understand the thing. Just listen it. Let's take one more example. Okay. Okay. Let me draw it properly. Okay. Obviously, let us take this value is R1, correct? And this bigger radius is R2. Now the current is going like this. Okay. Now the current is going like this from inside to outside. I am getting my point. Like it is like this. The length is L. And this is the current is going like this. Now can you directly write the resistance? Then what is the resistance? First tell me, can you directly write, or what you have to do? If you don't write, then how to solve it? Just think for a 1 minute. Okay, just give me just think for a 1 minute. How to write the resistance? Just try to think. That how will you write the resistance for this? Okay, can you directly write the resistance, or you have to do something? Can we directly write the resistance here? Answer is no. Why we can't write? Because if you try to understand, the current is going like this. Okay, so basically the current is going like this. So if the current is going like this, if you try to understand, the area is increasing. The area is increasing. Initially the radius is r1, now the radius is r2, so area is increasing. The length is remains same, length is L only, but the area is increasing. So what we have to do now? What we have to do now? We have to now do the integration. So what I am going to do? We have to now going to integrate this surface. We have to now going to integrate this surface. So let us do the integration. So how we will do? First we have to take the element, and now how to take the element? Let us see here. Basically this is our case. We have a two cylinders are there, or you can say two surfaces are there. So what we will do, basically from center I will go to distance of x, and I will take a small disk. Okay, a very small disk, very small. Okay, whose thickness is how much? How much is the thickness? Thickness will be dx. A small strip I will cut, whose thickness will be dx. Okay, now for this first I will, it's a small ring type. Okay, for this I will write the resistance. For this, generally only for this step you try to think. Basically I am doing like this, I am cutting a small strip here. Okay, whose thickness is dx. It is like this, a small strip like this. Okay, now for this strip you try to write the value, try to write the basically the current R resistance. R is equal to, how will you write? First you tell me what is the length. What is the length? See, for this strip you have to think, don't think about the others. If you see the strip, it is like this, a small strip is there. The current is crossing this surface. So how much length it is crossing? The thickness of this strip, that is dx. The length is dx. Correct? Correct here. Now what is the area? The area is basically the area which is perpendicular to the current, and this area is perpendicular to the current. What is that area? That will be how much? This will be the area of this strip. Correct? It is x. So what is the area? Basically it will be 2 pi x, that is my length, into width. What is the width of this? What is the width? See, this is my strip. Correct? So what is the width? What will be the width? This is my length into width is the area. Length is 2 pi x, circumference, that is my length. What is width? You have to think basically. It is all about thinking. Try to imagine the things. The length will be L. Sorry, width will be L. Obviously, this is my width, that is my length. So overall, the area will be 2 pi x into L. Now what you have to do? Now you try to think. I will cut this number of strips, and the current in through every strip is same. So it is a series combination or parallel combination? Obviously series combination. Just integrate it. What will be my limit? From R1 to R2. If you integrate, what you will get? This is a small resistance dr. So it will become capital R is equal to rho 2 pi L into ln R2 by R1. This is my resistance. Are you getting my point? You have to imagine the things here, then only you can write the answer. This is a previous year question also. Some, I think for NEET they have directly asked this formula, and for JEE they like, I think it's in the JEE. I remember it is previous year questions of JEE, and for this is a previous year question for NEET. Okay, this is a previous year question of NEET, and this is the previous year question of JEE. So you can see there is only what is the difference here? They same concept they are using, but there is less mathematics and there is more mathematics. That is only the difference. There is no difference in the concept. Concept is remains same only. Only the difference is the mathematics. Okay, clear here? Anyone have a doubt? Let's take one more example. Okay. Let's take one more example. Okay. Okay. I hope many of you have solved this example. That what I think many of you may have done this question here also. Because this is a very famous. Every coaching institute solve this. Let me also do this because we are teaching everything. Let's solve this also. Okay. And suppose this value, sorry, this is my center, my center are coinciding each other. Okay, both the center are as clear, and suppose the radius of this is a and radius of this is b. And what is the direction of current? The current is going like this. Suppose this distance is they have given as L, and current is going like this. Obviously current is going I. Okay, you have to find R resistance. Just think about it for 2 minutes and then solve it. You have to find the resistance R. Think it. How to solve this? How to calculate the resistance? What is the approach? What is first? You tell me what is changing here. What is fixed? What is changing here? See, you have to think. Otherwise, they can give you any geometry, okay, and they can directly ask you to calculate. So that why you have to think. This is also a previous year question only. Okay, so first tell me what is changing here. What is fixed? Area is changing because you can see initially the radius is small, now the radius is increasing, so obviously area is increasing, length is remains same. Okay, so what we can do, we can take another similar element like that. We can take a some element. So let us take a some element here. Solution, let's take this. Oh sorry, I'm just for the convenience I'm increasing this, like raise this thing, and I'm writing current here. I'm taking a small element. Correct. And suppose this distance is r. Is it okay? From this from the center x, I'm taking this element. Correct. Okay. So for this thing, I want to write the, and suppose the thickness is dx. I want to write the resistance. So how will you write? Small resistance dr. That is rho. Rho is given, obviously rho. What is the length you will take? First tell me what will be the length. The length will be obviously sir dx. What is the area? Pi r square. Correct. Pi r square. This is the radius, so pi r square. Okay sir, clear. Now it is a series. See, whenever you have to see whether it is a series or parallel, just do one thing. If the dx is coming in above, that means it is a series combination, and if it is coming below, that means you have to a parallel combination. So you just reverse it, then integrate. Obviously. But now the problem is that here we have a r is also a variable and x is also a variable, and two variables, and we have how we can integrate. That means to do this integration, either we should know r in the term of x or x in the term of r. So let us think about this. So here we have a mathematics. What is a mathematics here? If you treat it like a straight line, suppose this is my straight line, okay, you can see this point is how much? This point is 0 comma a y-axis. And what is this point? This point is how much? If this is my origin and this is obviously origin, so this point will be my 0 comma b, correct? And this is my origin, and this length is given as L. Now can you write the equation of this straight line? Basically, can you write the equation? And this distance is, at some point this distance is r, and this position is x. Can you write the equation of this straight line? Yes. So what is my r? Means y coordinate. Y is equal to mx. What is slope? b minus a divided by L into x plus c. What is a constant? Constant is intercept, that is a. Correct? That is a thing. So y is equal to mx plus c. Now just find dx thing. Now just either you can replace r by this thing, or either you can find the dx. So it is better to find the value of dx. To just differentiate this, you will differentiate, so this will become dr. This thing is b minus a into L divided by L into dx, and the differentiation of constant is 0. So from here you can put the value of dx here. So what is the thing you will get? You will get dr is equal to rho. What is the value of dx? Dx value is L divided by b minus a into pi divided by dr but a r square by r square, correct? Now what is the integration limit? The limit of integration is from r is equal to a to b, correct? A to b. Clear? So let us do this integration on the next page. So what we have got? We have got dr is equal to integration from a to b, okay, dr upon r square into rho divided by b minus a by pi, correct? This is the only the equation, no? Sorry, L is also there. L is also there. Yeah, L is also there. Just integrate, what you will get? Rho L upon p minus a into pi. Integration of this is minus 1 upon r. You have to put the limit a to b. Upper limit minus lower limit, what you will get? Rho L upon b minus a divided by pi. So what is the value you will get? You get 1 by a minus 1 by b. Is it correct or not? B minus a, sorry, this this is correct. Okay, so what this will become? I think I am doing something wrong that. Okay, so what is the thing you will get from here? I'm writing here. So what is the thing you will get? You will get rho L upon b minus a into, in numerator again b minus a divided by ab. So this thing will cancel out. So you will get r net is equal to, for this configuration, is equal to rho L upon something I missed. Yeah, pi I missed. Here we have a pi, that is pi. This is my answer. Clear? So this is how you have to build your thinking approach. Basically, this is how you have to think. I hope it is clear now. What you have to do? Again, this is the same thing, but here it is a simply. So in this case also we have seen the variation of area. In this case also we have seen the variation of area. So that is what I am saying. They will repeat the concept. They won't repeat any question. In competitive exam or any exam, there is a repetition of concept. There is no repetition of question. So see, here also area is varying, here also area is varying. Is this both the questions are same? No, the questions are different, geometry is different. So the concept is repeating, but but the question is not repeating. That is what I am saying. Clear? Okay. So let us proceed further. Let us take one more example. Okay. Let us take one more example. Okay. Give me 1 minute. Um, let us take okay. Uh, Suppose this is my some sector. Okay. Okay. And suppose this is the center. I hope you are getting the point. Basically, what I want to do, let me draw it properly. Let me draw it. It should be straight. That's why. Okay. Sorry, sorry. Okay. Suppose it is a sector like this. Are you getting my point? Are you able to draw? First, draw this. Okay. Suppose it is a sector like this. Sorry. Okay. Basically, from cylinder, what I did, I cut a one small sector. That is what I did. Okay. Sorry. This thickness and this thickness are equal. Okay. I'm not able to draw it properly. Suppose this is A and the outer radius is B. Okay. And anything else is given. Mm, suppose let me draw this for 3D, then you will understand it better. Basically, what I'm trying to say, suppose this is one square. Basically, it is something like this. Are you getting the point now? Okay, it is something like this. I hope now it is clear for you. Let me draw it more properly for you. This thing I am drawing in 3D. In 3D, if you will see, it is something like this. It is something like this. Correct? Now you are getting this point. It is something like this. Clear? Okay. I hope now you are understanding the picture. What it is exactly. So it is something like this, and suppose the current is flowing like this, means I am trying to say the current is flowing like this. Suppose this is the current is going like this. Okay, suppose the current is going like this, inside like this. Are you getting my point? Basically like this. I am 3D, I have drawn this structure. Now I hope you are understanding. Now for this thing you have to find the resistance. Okay, now calculate the resistance for this. It takes too much time to draw it. Or in place of this, let me do slight more change, otherwise this will be more easy. Let me make slide difficult for you. Easy. What we can do, let us let the current flow like this. Now it is more easy. Sorry, now you solve. Is the current is going like this? Are you getting my point? It is not like this, it's like this. Now you solve. It is slight difficult, you have to think now. That one will be the similar case na. That's why I have removed this. This is now this one you think about it, how to basically solve this. Now in this, can you tell me now what is changing here, length or area? First you tell me that, then only we can solve this question. What is changing here? Length is changing or area is changing? First you have to decide that whether it is length is changing or area is changing. What is the thing which is changing? Can you tell me here what is the thing which is changing? See, and one more thing is given. Yeah, this height is given as h. Okay, okay. So you tell me what is the one thing that is changing here? Here what is changing? Obviously here the length is changing. Length is not fixed here. Okay, area is not changing. Here we have a length variation. Now if we have a length variation, then how to do this? Basically what we are going to do, we are going to take a strip. Okay, one small strip we will take like this. We'll take a one small strip like this from center. Suppose this is my center. From center x we will take a small strip whose thickness will be dx, correct? And then we will this strip will go like this. Are you getting my point? Correct. If I show here, from center at distance x, I am taking a small strip like this. This is my strip, correct, whose thickness is dx. So for this, if I want to write the resistance dr, it will be rho into L. What is the length? The current is going like this. So what is the length? If you will see, this is my length. So can you tell what is the length? That will be pi x by 4. Pi x by, sorry, not pi x by 4, it is pi x by 2, because 2 pi x is the total length. So 1 by 4 will be pi x by 2. Now what is the area? If you will see the area, this is my dx and that is my height h. This will be my dx and that is my height h. Now you can see here we will have a parallel combination because the dx is coming here, and also you can see from here also, we suppose here the potential is V at this node, and then this node a potential is 0. So at every step will come like this, they will have a same potential. So we can say obviously here we have a parallel combination. The resistance will be connected in parallel. That's why you can see the dx is coming in denominator. So what is my R net? My R net, how will I calculate? How will I calculate? I will first reverse it because it is a parallel combination, and then I will do the integration. So it will become rho pi x by 2 into dx, and h will come in the numerator. So it will become how much? H into rho pi 2. Integration of dx, what is the limit you have to put? From x is equal to a to b, you have to integrate dx with respect to x. So what is the value you will get? You will get 2h by rho pi, correct, and this will become ln by correct? This much ohm is the answer. I hope you got this thing. If you have any doubt, please tell me. Note it down. Do you understand this thing? It's basically, here we have a what variation? Sorry. Here we have a length variation. In previous example, we have seen the area variation. Here we have a length variation. The length is varying. The length is continuously varying. Clear? Any doubt? Let us move to another example. I'm taking the same question. This is A, this is B. Okay, I hope now you get the point. Okay, and let me draw this in 3D also. Basically, the diagram is like this. Okay, okay, the diagram is like this. It is in 3D. This diagram is 3D, and now the current is going like this. Now you tell me. You're getting my points? Means the current is like this. Okay, like it is like this. So, or you can say it is like this. Okay. Now you have to find the resistance. What is the resistance? This is an example. Now here again you have to think. Use your brain and think, and now you tell me what is going to be the resistance here. How to calculate the resistance? Think of it. First you think which is varying, whether area is varying, length is varying. Then try to write the resistance due to the small element. Then after that is small element, then try to basically write the try to see whether it is series combination or parallel combination. Then after that you integrate. That is a simple steps. Yes, 3 simple steps are there, but you have to use it. Okay, so first what you have to do, first you tell me whether it is a length variation or area variation. Which thing is varying here? If you try to understand, which thing is varying here? Obviously it is a area variation, because initially the radius is A, now the radius is becoming B. So it is a area variation, that is clear. Okay, so now take a small strip. Now take a small strip like this, as we have taken. This height is obviously h is given there. This distance is dx. Now take the small strip. This is my small strip, correct? From center x, means if I show here from a center x distance, from a distance x from the center, a distance x from the center, I am taking a small strip like this, whose thickness is dx, correct? Now let us solve this. Okay, let us write the small resistance dr. Current is going like this. Okay, rho. First tell me what is the length, just for that strip only. What is the length? What is the length? You have to tell me what is the length. You have to tell me what is the length. Now the current is going like this. So what is the length along the direction of the current? That is dx. What is the area? This area they are crossing. This area. So what is the area? Length into breadth. What is the length? What is the length? This length. And what is the breadth? The height is h. So what is the length now? Can you tell me? Length we know. It is the arc, na? Pi x. That is the length we know. And the height is h. It is series or parallel combination. Obviously the current is going like this, so it is a series combination. We are getting dx above. So directly integrate. Obviously. So rho by pi h. Basically series combination means where the current is same. X is equal to a to b and dx, and what is the value? It is x. So you will integrate, you will get 2 pi h into rho ln b by a. Correct. So this is my resistance due to this. I hope it is clear now. So here we have a length variation. Sorry, not length, area variation. So here we will have a area variation. Clear? Okay. Let us give you one homework for this case. If in this question only, if in this question, same question, let me just copy it. Who will going to draw it again and again? Let me just copy it, okay? Because I can't draw it again and again. In this same question, I am doing only a small change. Now you understand what is a 3D diagram, so I have to no need to draw it again. I am giving you this homework. You will tell me the answer in the next class. Suppose in play now the current is going like this inside. Like this means this is now this is my strip and the current is going like this. Are you getting my point? Now the current is going like this. So what is my resistance? That you have to write. If you understand all the concepts, then you can directly write this answer. Even no need to do anything. First you will think this, whether it is length is changing, area is changing. On the basis of that you will write, okay? And everything is given, resistivity is given, that is rho. That is our your homework question. You just write the answer and comment in the comment section. Clear? Okay. So in this session, what we have seen basically about the resistance. We have talked about the resistance. We have understand all the concepts about the resistance, how to write the resistance. We have seen the different examples, and we have seen about the different examples. We have seen how to write do the calculation when length is varying, area is varying. Okay, these are the two variations we have seen, and this is the best example basically, where we have in this same example we have seen the length variation as well as we have seen the area variation. And you have to answer me this, you have to answer this question to me, what is the resistance for this. Now in the next session we are going to start with the properties of the like some conductor. We will do the basic discussion, and then after that we will finally move to the very important part, that is solving a circuit. How to solve the different types of circuits. That is basically we will learn about how to solve the different circuits, calculate the current, and different things. Different things we will see, different theorems we will see the KCL, KVL. There are a lot of students who face problem in writing the KCL and KVL. They are not able to write the KCL and KVL properly. So we will understand these things and I will give you the very short method, very short trick, so that you will never get confused while writing the KVL and KCL. You can write it just in a single minute, whether it is any type of circuit, it doesn't matter. And like in while come to the circuit, there are the different, like different peoples are there, they used to give different methods. For this circuit apply nodal analysis, for this circuit apply mesh analysis, blah blah blah. No need of all this thing. We will solve each and every question by using KCL and KVL. No need to apply anything. Only KCL and KVL is more than sufficient at your level to solve all the questions. There is a no need of any type of any theorem. This will come into your, when you will go for highest, then there you will learn about these theorems and this nodal analysis and blah blah blah. A lot of other things are there. At your level, only KCL and KVL is more than sufficient to solve all the questions. All the questions. I will solve in front of you. I will solve all the questions from all the book, like famous book DC Pandey, SC Verma, all questions just by using KCL and KVL. No need of any other things. We will do that. Till then, if you like this session, please like it, share it, subscribe it, and have a nice day and take care. Thank you.